Hello everyone. We are discussing machining sciences and tool design. So we are in module 5, that is design of single point cutting tools. And in this video, we'll be discussing about the topic orthogonal rake system. In the previous video, we have seen about MRS, that is maximum rake system. So this is about orthogonal rake system, which uses three mutually perpendicular planes as a reference for measuring various tool angles. So whereas in MRS we are using only two mutually perpendicular angles for measuring the tool angles, where here we are using three. So that is the difference between MRS and ORS. So these three planes are, one is reference plane, that is rake reference plane, which is perpendicular to the cutting velocity vector VC, and I'll show that angle in a next slide. And then cutting plane, so it is a plane perpendicular to the reference plane and contains a principal cutting edge of the tool. And then you have an orthogonal plane, that is plane perpendicular to the reference plane phi r and also perpendicular to the cutting plane. So these three planes are mutually perpendicular to each other, which is used for measuring the various tool angles in case of a orthogonal rake system. So all the angles are shown here. So here you can see, so this is pi r, so that is orthogonal, that is rake plane, and then this is pi c, this is the cutting plane, and this pi c is the angle which you can see from this end, and this is the cross section of it. And then pi naught, that is orthogonal reference plane, orthogonal plane, so that is given as a pi naught, and this is pi r, that is rake plane, that you have these three, that is reference plane. So these three planes are shown here, pi c, pi r and pi naught. So you have other angles also which is shown in this figure, that is you have a inclination angle lambda, so that is shown here. So this is inclination angle, so it is the angle of the inclination of a tool's principal cutting edge from the reference plane pi r. So with respect to this, what is the angle of the tool's cutting edge, principal cutting edge? And then you have a orthogonal rake angle, that is given here. So it is the angle of orientation of tool's rake surface from the reference plane pi r, that is again the reference plane pi r, and measured on the orthogonal plane. And then you have a orthogonal clearance angle, that is alpha naught, which is shown here. So that is in this sketch. So this is alpha naught. So it is the angle of orientation of tool's principal flank. So this is the flank surface from the cutting edge plane pi c, that is with respect to this angle. I have erased all other angles here. So now we will discuss about other angles which is given. So auxiliary orthogonal clearance angle, so which is given as alpha naught dash. So this is an angle of the orientation of a tool's auxiliary flank surface from the auxiliary cutting plane pi c naught. So that is this, okay, that is pi c dash, and measured on an auxiliary plane pi naught dash. So this angle is called as an auxiliary orthogonal clearance angle. And then you have a principal cutting edge angle phi, so that you can see here. So this is the cutting edge, main cutting edge, and this is auxiliary cutting edge. So pi is the principal cutting edge angle between cutting plane pi c, that is this, and then which contains a principal cutting edge, and longitudinal feed direction measured on a reference plane. And then we have a phi 1, so that is shown here. So this is phi 1. So as you can guess, the angle between the auxiliary cutting plane pi c dash and which contains an auxiliary cutting edge, so that is about pi 1, that is auxiliary cutting plane pi d dash, and the longitudinal feed line measured on a reference plane. And then lastly, which is shown is nose radius, so which is nothing but a curvature at the tool tip. So it should be noted that in ORS, nose radius value is expressed in mm. So that is about ORS and how it is designated. So the tool designation is as shown here. The first number indicates the lambda, that is inclination angle, and then it indicates orthogonal rake angle, and then orthogonal clearance angle, auxiliary orthogonal clearance angle, and then auxiliary cutting edge angle, principal cutting edge angle, and the nose radius. So for example, if it is given as this, as shown here, so if it will be written as 0, 7, that is -7, and then 10, 8, 15, 60, and then 0.8. So as we just now discussed, 0 is inclination angle, -7 is the orthogonal rake angle, and orthogonal clearance angle, orthogonal auxiliary orthogonal clearance angle, and then auxiliary cutting edge angle 5.1, principal cutting edge angle 5, and the nose radius 0.2, which is in mm. So if, for example, if it is given as -6, -6, 10, 15, 15, 45, 1.2, so you need to read it as inclination angle as -6, and then orthogonal rake angle as -6 degree, orthogonal clearance angle as 10 degree, or auxiliary clearance angle as 15 degree, principal cutting edge angle, so auxiliary cutting edge angle as 15 degree, principal cutting edge angle as 45, and then nose radius as 1.2 mm. So that is about ORS system. So I'll end this video here. Thank you.